my name is Sergiu Simpalean and I want to talk to you about our project for the Digilent Design Contest 2012. Our project is called Automated Self-Parking Assistant and it's a two-mode project. On the one hand, it assists the driver during parking by telling him the distance to the cars parked behind and in front of him. If mounted on an appropriate car, it can search for a parking space long enough and park the car in its own. The project is a work in progress and has undergone a series of changes since the original design. These changes range from expanding its repertoire to other types of parking to the exact parts that we will use for our implementation. Now, I want to discuss a bit about how our system works in the automated mode because this is the interesting part. The car drives along the row of parked cars and uses a sideways mounted IR rangefinder to detect the gaps between the cars. By means of an encoder mounted on the drive motor, it keeps track of the distance it traveled, thus being able to calculate the distance. Once it knows the dimensions of the space, it computes the trajectory of the ideal path and positions itself to the starting maneuver. We added fail-safe systems by incorporating sensors to determine the distance to the front and to the rear of the car so it can stop in case of unexpected obstacles such as a pedestrian or other obstructions not found by the IR sensor. Our system also features an accelerometer to determine accelerations on 3 axes. Horizontal acceleration acts as a sort of kill switch, while horizontal and vertical accelerations tell the microcontroller that there is a small obstacle, in most cases a curb, which cannot be seen by the IR sensor and asks to recompute the trajectory for the updated dimensions of the parking space. Now I will show you part of the diagrams and calculations required for the above mentioned computations. Now to our implementation. The whole system is mounted on a Lego car, which we built in order to mimic a real car as close as possible. It features a proper and precise steering system, a gearbox which enables selecting front and reverse without stopping and reversing the motor just as in a real car, a differential and a crude pendular suspension. While it may look odd, its dimensions and ratios are up to scale, 1 to 14. The implementation we chose enables the system to be scaled up and mounted on a real car. The only requirements for the car are to have automatic transmission, because while our car can handle gears, our system can't handle the clutch, and electric power steering. And now for a little drive test. Note that the car is just randomly moving around to demonstrate its dynamics. However, it cannot do anything really smart, since we are currently switching to new rangefinders because these are very inaccurate and the other ones have not arrived in time for this film to make the pre-evaluation submission date.